This video will cover adding and subtracting rational expressions. And just to note, in the Big Ideas Math textbook, this is also section 7.4 in the Big Ideas. So if that's something that you like to use to look at other videos or other materials, that is where you would find it, lesson 7.4 in the Big Ideas. Basics on adding and subtracting fractions, and we worked on this a little bit yesterday in class, so you're aware of some of this. When you add, you have to have a common denominator, and what you do is you add the numerator and you keep the denominator the way it is, and so you just add that way. And now you want to reduce anything that you can. So 3 goes into 6 twice, and 3 goes into 9 3 times, and so my simplified answer is -2/3. Same thing if you have any kind of variables. We still have a common denominator, and so we're going to do the same thing. That is, we're going to keep that denominator the way it is, and we're going to add the numerator together. And so that would be your answer for example B. Example C, again, we have a common denominator, so we're going to keep it. The only thing different on this example is a subtraction problem, and when you do subtraction, just make sure that you remember that you're subtracting both of them. So take a second to think in your head of what this is going to be. And so your answer is going to be x plus 3 over x minus 5, because 2x minus x is x, and 1 minus -2 is like 1 plus 2, and that is x plus 3. Okay, well, what if you don't have a common denominator? Well, again, you worked on this the other day on the Delta Math assignment, but I want to just take a second to break it down, because some people automatically know what a common denominator would be, some people don't. And some people just always opt for the biggest one, which in this case would be 180. But there is one smaller than that, and I want to talk about how to get to it, because you can then use that skill when we get to more complicated problems like the ones below. So I know that 10 is 2 times 5. That's a prime factorization, is 2 times 5. And the prime factorization of 18 is 2 times, well, it's 2 times 9, but I have to break that down further. So it's 2 times 3 times 3. That's the prime factorization of these two denominators. And so now when I'm looking to find a common denominator, what I want to do is look at these two. They both have a 2 in them. That's good. But I also need to make them match. So in other words, there's a 5 over here on this first one. I need to put a 5 over here also. And this one had a 3 and a 3, and this one over on the left doesn't. So I need the 3 and the 3, or in other words, a 9 on this side. Now, I could leave it like that if I wanted to. I could just leave it written out factored like that. Usually we don't. Usually we go ahead and say that this, when I multiply this together, 9 times 2 times 5 is 90. And same thing over here, 2 times 3 times 3 times 5, that's also 90. And so my common denominator is 90. But I wanted to break that down for you to show you how that works. Because now in our numerator, since we multiplied this one times 9, we also have to multiply the numerator times 9. And since we multiplied the denominator on the right times 5, we have to multiply the numerator times 5 also. And now, again, we keep our common denominator and we just add across the top. So that's 63 plus 55, which is 118. Now, of course, we do need to simplify that one more step. And I'm looking at this and I'm thinking, what's my common denominator? The only common denominator here is 2. So I'm just going to have divide by 2, and I get 59 over 45. Okay, so the reason I broke that down like that is because that's the method I'm going to use on this next example. Again, they don't have a common denominator. This one has an x, this one has a 2. They have absolutely nothing in common. So over on the right, I need an x. And if I have an x on the bottom, I have to have an x on the top. And on the left, I have an x, but I need a 2. And I'm going to go back to a phrase that I heard from Mrs. Weigel, which was multiply by 1 in disguise. So we can multiply by x over x because that's just 1. And we can multiply by 2 over 2 because that's just 1. Okay, so now what do I have? I have 16 plus x all over 2x. Can I simplify that? Can I cross out my x's? Or maybe make this 16 over 2 into an 8? No, because they are not common factors. That numerator cannot be factored any further, so that's as far as I can go. That's the same technique I'm going to use on example C. This one has an x and an x minus 2, so I need an x minus 2 over here. Now, I have a common denominator. I'm going to keep that, but I do need to add my numerator. So I have 5 plus, I'm going to go ahead and distribute 7x minus 14. And now I need to combine like terms in my numerator. I have 7x minus 9 all over, and I keep that denominator. Now, people always want to know, should I distribute? Should I not distribute? Should I factored form? Should I have it in standard form? So over here I wrote a little note for you. Here is what I typically go by. Now there are exceptions, but typically this is what I go by. In the numerator, you want to go ahead and distribute it and simplify it. And then finally, if you can factor it, go ahead and factor it. But before you factor it, you have to distribute it and simplify it first. In other words, combine like terms and things like that. In the denominator, you want to leave it in factored form. And the reason is so that then you can go back and cancel. If you have factors that can cancel, you can do that in factored form much easier. So I like to leave mine the way I have it here. That is 7x minus 9. That's all the way factored out, combined like terms, everything, distributed, combined like terms, whereas the denominator is still in factored form. That same thing with a common denominator applies when you have it longer like this. I have an x minus 1 on the left. I have an x minus 1 on the right. But the left, it needs an x minus 4 because that was over here on the right. Well, if it's on the right, it has to be on the left also. And then the right, it needs the x plus 2. Now I'm going to follow those instructions I was talking about over there on the left-hand margin. And that is, I'm going to go ahead and distribute my numerators, but I'm going to leave my denominator in factored form. So my denominators are the same, so I'm going to have the same one down there, but my numerator I need to distribute. Okay, I distributed my numerator. That's going to be 5x squared minus 20x. Now, remember this minus sign. Gives me a minus 4x and a minus 8. Okay, so don't forget that negative sign. Now, I keep my denominator the same. I want to combine my like terms, so I've combined my like terms to be like this. If that numerator can be factored, we do want to go ahead and factor it. Looking at it off the top of my head, I don't know if that can be factored or not. One way to check if it can be factored or not, I'm going to come over here, is you can kind of start testing with the AC method. So 5 times negative 8 is negative 40. Now, are there any factors of negative 40 that would add up to 24? Well, let's see, like a negative 4 and 10, that doesn't work. Negative 2 and 20, that doesn't work. Negative 1 and 40, no, that doesn't work. So I'm going through there's just nothing's going to work. It's not going to happen. So this cannot be factored. And so I'm done with this problem right here. Okay, we have done a lot of examples, and I don't think we have to overdo the examples. So I'm going to skip E and F for now. Those might be ones that we could do tomorrow for warm-ups in class. But I want to just look at G and H. There's not a lot different, but just enough that maybe it's worth going ahead and doing G and H. One thing about G and H is it's not factored out. And so we have to factor it out first. So let's go ahead and factor this. The left-hand side is factored, but the right-hand side is not. Okay, so now it's factored, and now we can see there's an m plus 3 and an m plus 3. The only thing we're missing is the m minus 3, and so we need that on numerator and denominator. So again, on the numerator, I go ahead and distribute it out. But on my denominator, I leave it in factored form because I need to combine my like terms. Now, this cannot be simplified any further. If it makes you feel better and you want to go ahead and factor out your numerator just to double check, you can certainly do that. And you come up with this. And the reason I say that is it kind of looks like maybe there's something should be factored out, but it doesn't work out that way. There's nothing that can be factored out. By the same token, if you wanted to go and just multiply that bottom just to, I don't know, just feel like it was complete, you could do that. But if it were me, I would just leave my answer like this, but I would take this other answer, and if you want to multiply that out in the bottom, I would take that answer too. Okay, last example is, again, we have to factor this first. So I'm going to factor out a GCF on this one, and I'm going to factor this one with a trinomial. And as I do that, I can see they both have an x plus 2, but the left-hand side needs a 4, and the right-hand side needs an x minus 6. Okay, so my denominator, it's a common denominator, I'm going to keep that there. My numerator, I'm going to multiply and simplify. So I've multiplied that to get 4. I've multiplied this one to get 3x squared minus 18x. I do want to leave it in standard form at the very least. So I'm going to go in and rearrange that so that it's in standard form. Now, again, I might be able to factor that. I'm not sure. Even if I factor it, it would have to be able to cancel with one of these to actually matter. But I'm just going to test it and see if I can factor it. My AC would be 12. Factors of 12 that add up to negative 18. I don't know, negative 12 and negative 1. Well, that's not big enough. That's as big as we can go. I don't know, negative 3 and negative 4. No, obviously not. Negative 2 and negative 6. No. So this is not going to factor, and so I can just leave it like that. I do not need to go any further. Okay, that is our lesson on adding and subtracting rational expressions. Again, the main thing, you need to have a common denominator, and you need to know how to create that common denominator.